Welcome back to another episode of Insects for Fun. Today, we're getting into something crafty with insects that use tools. Turns out, it's not just chimpanzees or crows. Bugs are out here working smarter, not harder. Some of the information in here has been talked about in bits and pieces on earlier episodes of the show, but today we're really going to explore different orders and families of insects that use tools and go into how they do it. Tool use has long been considered a hallmark of higher intelligence, but more and more scientists are discovering that insects can be incredibly resourceful. From ants building bridges with their bodies to wasps using pebbles as weapons. Today's episode is crawling with cleverness, so let's get into it. Number 1 on our list shouldn't be a surprise to most because ants are indeed champions of teamwork. And tool use in ants has actually been well documented and is impressively diverse, as you'll soon learn. We're going to start off with a special ant commonly known as weaver ants, genus Oecophylla. These ants actually use their own larvae as glue guns. We'll do a deep dive into these on a different episode, but basically weaver ants are known for building intricate nests by pulling leaves together. However, to keep them together requires silk from their larvae to act as binding material. The worker ants literally carry larvae in their mandibles and tap their abdomens to dispense silk, exactly where it's needed. Talk about teamwork and multitasking. Next up, we've got black imported fire ants, Solenopsis richteri, which have been observed using sand grains and sponge-like materials to soak up and retrieve liquid food. Ants, as you know, don't have sucking mouthparts, and they simply can't drink up fluid from deep wells. As a result, they drop in porous material, letting it soak, and then carry it back to the colony like little delivery sponges. In the case of sand, maybe there's a small pool of water or a well of sugar water in a plant that they can't reach. The ants will carry and drop sand into the well on the side until it goes up and reaches the surface. The water tension carries the water up for the ants, like taking a piece of cloth and dipping one end into a drink. Second to last on our list of ants would be myrmecine ants, which happen to be the largest subfamily of ants, and as a result, don't have a common name. Ants in this subfamily have been known to use debris as weapons. Specific species examples would be Phaedal oxyops and Phaedal obtusospinosa, which have been observed using debris, soil particles, and plant fragments as both projectiles and barriers during conflicts with other colonies. These ants fortify their nests or even lob debris at enemy ants to impede their advance, which functions as both defense and aggression. Other myrmecine ants, like Myrmesa sabuleti, apply resin or antimicrobial plant debris to their exoskeletons, effectively self-medicating. They either drag the material over themselves or mix it into their nests. This acts as armor against pathogens, and in some cases, deters predators or rival colonies. Now, last but not least, we have an ant that self-medicates through drinking poison. Camponotus castaneus, a formicine ant, ingests naturally occurring hydrogen peroxide. They do this in low concentrations to combat internal fungal infections. These ants know exactly how much to ingest to prevent their own death, which is incredible given that they aren't following a prescription. Okay, let's now move away from ants to look at some wasps and bees, starting with one that builds stone walls. Sand wasps, in the genus Ammophila, are masters of nest security. After laying a single egg and stalking the underground nest with a paralyzed caterpillar, the mother wasp uses her jaws to pick up pebbles or dirt clumps and drop them on the entrance. She doesn't just pile things randomly. She carefully selects and arranges materials to conceal the hole. This behavior discourages parasitic wasps and predators from finding the larva. Next up, we have a bee that uses leaves. That's right, leafcutter bees and the family Megachilidae gather leaf or flower petal fragments, cut them into perfect ovals, and use those to line and seal their nesting tubes. These bits create waterproof chambers that protect developing larvae. Some species even layer petals in color-coordinated fashion. Tool use and aesthetic taste. That's a win-win. Now, branching off from bees and wasps, let's take a look at bagworm moths. We've covered these insects before in the past, and they certainly deserve a spot in today's episode as well. Bagworm larvae make cases out of silk and whatever materials are available: twigs, sand, flower petals, even snail shells. And unlike leafcutter bees, these elaborate cases are mobile and continuously being upgraded. The larvae use these cases as an extension of themselves, and as they grow, so do their cases, ensuring both camouflage and protection. Some species even close the case off during pupation, like a DIY sleeping bag. But these aren't the only insects to take their creations on the road. Some assassin bugs actually use the corpses of their prey as camouflage in horror fashion. Assassin bugs feed on other insects by piercing them with their straw-like mouthparts and sucking them dry. And species like Acanthaspis petax pile the remains of their victims on their backs. The corpse stack masks their scent, disrupts their silhouette, and even deters other predators. This morbid backpack serves both passive and active defense. But tool use doesn't necessarily have to be in the context of physically touching or making something. For example, many insects rely on natural things, such as the moon and sun, for navigation. One great example of an insect that uses the sun for navigation would be the monarch butterfly. These butterflies use a time-compensated sun compass, meaning they track the position of the sun across the sky and adjust their internal sense of direction according to the time of day. Basically, they have a built-in watch and GPS. They can also rely on a UV light-dependent magnetic field compass on overcast days, the details of which are incredibly difficult to understand, let alone explain. But basically, monarchs that migrate know where to go thanks to the sun and the Earth's magnetic field. Now, let's look at an insect that displays two forms of tool use, both physical and navigational: the African dung beetle, Scarabaeus satyrus. Now, if you're a long-term listener of the show, then you might remember me mentioning this species on my dung beetle episode. But basically, this species of dung beetle uses the stars as a navigational system. Just like olden day sailors and travelers, these beetles are able to roll their dung balls to new territories by looking at the Milky Way as a sky map. The beetles climb atop their dung balls, perform a dance to calibrate their direction, and then take off in a straight line. Alright, so we've seen a variety of insects and a variety of tool uses today, but we can actually organize them into 5 categories. One would be construction tools, like weaver ants, leafcutter bees, and bagworms. The second would be foraging tools, like using sand grain to collect food in the case of black imported fire ants. The third is defensive and protective tools, like sand wasps burying nests and assassin bugs with their corpse armor. Next would be navigational aids, like dung beetles using celestial cues and monarchs relying on the sun. And finally, we have chemical tools and self-medication, like ants applying resins or plant matter. Insects might not build iPhones, but their behavior often fits within the scientific definitions of tool use, which is the manipulation of an external object to achieve a goal. And that's going to wrap up today's episode. Thank you as always for listening to the podcast. And of course, if you like it, please go rate the podcast on whatever platform you listen. 5 stars is super appreciated. And if you listen on Apple, if you could just leave a review, that would take it to the next level. Now, of course, if you want more Insects for Fun, you can check out the Patreon, where I have bonus episodes, vlogs, and ad-free episodes. I will catch you guys next time.